Okay, so let's see one more example on the empirical formula. So suppose you have been given 3 grams of an organic compound which contains carbon, hydrogen and oxygen only. So let's get started. We have 3 gram of organic compound, okay, containing carbon, hydrogen and oxygen only. So on combustion it gives 4.4 grams of, on combustion it gives 4.4 gram of CO2, 1.8 grams of H2O. So we have to find the empirical formula, and if one molecule of organic compounds contains 6 oxygen atoms, then find the molecular formula. So first we have to find the empirical formula, then molecular formula. Okay, so let's get started. So CO2 would be coming from the carbon of the organic compound. On coming in contact with the oxygen from the air, it will form CO2. Okay, so it is forming 4.4 gram of carbon dioxide. So from here we can say that number of moles of CO2 would be 4.4 upon molar mass of CO2, which is 44. This implies it has 0.1 moles. Hence number of moles of carbon atoms from organic compound which is coming in contact with oxygen would be 0.1. Okay, hence mass of carbon atom in organic compound would be 0.1 into molar mass of carbon atom, which is 0.1 into 12, which is 1.2 grams. Okay, next we have been given that 1.8 grams of H2O is also produced. So H2O would produce from H2 plus half O2 will be giving H2O. Okay, this is 1.8 grams. Okay, so number of moles of H2O present would be 1.8 upon 18. So number of moles of H2 in H2O would be, or rather in organic compound would be also 0.1, and mass of H2 in organic compound would be again 0.1 into molar mass of H2 would be 2, hence 0.2 grams. Okay, so remaining mass, that is mass of oxygen or O atom, would be mass of organic compound, which is 3 grams, minus mass of H2, which is 0.2, minus mass of carbon atom, which is 1.2. So this gives us 1.6 grams. Okay, so carbon is 1.2 grams, H2 is 0.2 grams, and oxygen atom is 0.6 grams. So number of moles of carbon would be 0.1. Number of moles, I'm talking about the number of moles of these elements or molecule in organic compound. Number of moles of H2 would be again 0.1. Okay, and number of moles of O would be again 0.1. Okay, 1.6 divided by 16 is 0.1. So CH2O would be the empirical formula. Okay, and now we have, for the calculation of molecular formula, it is given that one molecule of organic compound contains 6 atoms of oxygen. Then we know that molecular formula is equals to empirical formula N in the subscript. So it contains 6 molecules of oxygen, so N would be 6. From here we can say that the molecular formula for the compound would be C6H12O6. Okay, So let's see some of the terms now. We have first density, which is nothing but mass upon volume. Okay, mass is not dependent on temperature, volume is dependent on temperature, hence density is dependent on temperature. Independent of temperature, dependent on temperature, hence density would be dependent on temperature. Okay, so its units can be gram per cc, cubic centimeter, gram per ml, or gram per liter. We can also have kg per meter cube. So like this we can define the units. Let's define what is relative density. So relative density is density of a substance divided by density of reference. Okay, divided by density of reference. Okay, let's have for solids and liquids that the term is used to define specific gravity. Okay, and for that H2O we should be using specific gravity. Okay, so for solids and liquids we are defining it as specific gravity, and the relative reference we are using as H2O, relative or rather reference. Okay, so specific gravity for case of solids and liquids would be density of substance at, or rather divided by density of liquid water at 4 degrees Celsius. Density of H2OL at 4 degrees Celsius. So this is specific gravity which we define for solids and liquids. Okay, where we use water at 4 degrees Celsius as the reference. And for, let's say, gases and vapors, we use the term vapor density. Okay, again for that we use H2O, this is L, and H2OG at the same temperature pressure at which the gas also exists. So for this vapor density would be density of gas or vapor at a temperature pressure upon density of H2OG at same temperature pressure, or at same conditions, to put in other words. Okay, now we know that density of a gas is dependent upon, or rather density, we have seen this formula that pressure is equals to rho RT upon molar mass. So rho, or density, we are talking about ideal gas here. Okay, we have seen this formula for ideal gas. So density of a gas would be pressure molar mass of gas divided by R and T. Similarly, density of water or H2OG would be again pressure molar mass of H2O So I just this beg your pardon, this is not H2OG, this is H2G rather, hydrogen. Okay, so this is not water, this is hydrogen. Okay, so this is molar mass of H2O would be used rather upon R and temperature of H2G. Pressure and temperature are same, gas constant is same, hence vapor density is molar mass of G upon molar mass of H2, or M upon 2 is the vapor density of any gas at which is ideal at a temperature pressure. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing some examples on the same.